In the vast expanse of our solar system, far beyond the familiar glow of our sun, lies a realm of icy giants. Among them is Uranus, a planet shrouded in mystery, its turquoise veil hinting at the secrets it holds. It is accompanied by a retinue of moons, each a fascinating world in its own right, each contributing to the intricate ballet of gravity and motion. These moons are not just passive passengers, but active participants in the Uranian system, their gravitational influences shaping the planet's rings. Among this celestial entourage, there exists a small, unassuming moon named Ophelia. Though dwarfed by some of its larger siblings, Ophelia plays a crucial role in maintaining the delicate balance of the Uranian system. Through the lens of science, we can begin to unravel the mysteries of Ophelia and gain a deeper appreciation for the intricate workings of our solar system. Ophelia, named after the tragic heroine of Shakespeare's Hamlet, is a moon that embodies a certain ethereal beauty. It's a small moon, its dimensions modest compared to the colossal scale of the cosmos. Yet, its size belies its importance, for Ophelia holds a special place in the complex choreography of the Uranian system. Discovered in 1986 by the Voyager 2 spacecraft, Ophelia, along with several of its lunar companions, revealed the intricate structure of Uranus's ring system. Voyager 2's images unveiled a system of faint rings shepherded by small moons, their gravitational influence maintaining the ring's structure. Ophelia, it turned out, was one such shepherd moon, its gravitational pull acting as an invisible fence, corralling the particles of the Epsilon ring, Uranus's outermost and most eccentric ring. What makes Ophelia particularly intriguing is not just its role as a shepherd moon, but also its potential to provide insights into the early solar system. Like many of Uranus's moons, Ophelia is thought to be composed primarily of ice and rock, a relic of the primordial materials that coalesced to form the planets and their satellites billions of years ago. Studying the composition of these icy bodies allows us to peer back in time, unraveling the secrets of our solar system's birth. By observing how Ophelia shapes and maintains the Epsilon ring, scientists can gain a deeper understanding of the forces that govern these celestial structures. These insights can then be applied to other ring systems, such as those around Saturn, Jupiter, and even more distant planets orbiting other stars. In the annals of space exploration, the Voyager missions stand as testaments to human ingenuity and our insatiable thirst for knowledge. Launched in 1977, Voyager 2 embarked on a grand tour of the outer solar system, its path determined by a rare alignment of planets. After its encounters with Jupiter and Saturn, Voyager 2 set its sights on Uranus, a planet that had remained largely unexplored since its discovery in 1781. At the time of Voyager 2's arrival in 1986, our understanding of Uranus was limited. We knew it was an ice giant, tilted on its side, with a faint ring system. Voyager 2's mission was to pierce this veil of secrecy and reveal Uranus in all its glory. As Voyager 2 approached Uranus, its cameras began to capture images of the planet and its surroundings in unprecedented detail. Among the many discoveries made during this encounter was the existence of several previously unknown moons, small icy bodies orbiting within or near Uranus's ring system. These moons played a crucial role in shaping and maintaining the rings, their gravitational influence preventing the ring particles from dispersing into space. One of these newfound moons, a faint speck of light against the backdrop of Uranus's rings, was designated S1986U8. It wouldn't be long before this tiny moon received a more evocative moniker, one that would forever link it to the realm of literature and mythology. The International Astronomical Union, the body responsible for naming celestial objects, has a long-standing tradition of drawing inspiration from mythology, literature, and history. In the case of Uranus's moons, the IAU decided to name them after characters from the works of William Shakespeare and Alexander Pope. Given Ophelia's delicate appearance and its close association with Uranus's rings, the IAU chose to name it after the tragic heroine of Shakespeare's Hamlet. Ophelia, a young noblewoman driven to madness and despair, seemed a fitting namesake for this small ethereal moon caught in the gravitational dance of the Uranian system. The choice of Ophelia as a name for this moon adds a layer of symbolic resonance to our understanding of the Uranian system. Just as Ophelia in Shakespeare's play is a victim of circumstance, caught in a web of intrigue and betrayal, so too is the moon Ophelia subject to the relentless forces of gravity and orbital mechanics. Its fate, like that of its literary counterpart, is inextricably linked to the larger forces at play in its cosmic neighborhood. The name Ophelia evokes a sense of mystery and tragedy, qualities that seem to permeate our understanding of the outer solar system. Ophelia serves as a poignant reminder of the beauty and fragility of existence, both here on Earth and among the stars. Ophelia, like many moons in the outer solar system, is a diminutive world, easily dwarfed by the celestial giants it orbits. With an estimated diameter of approximately 46 kilometers or 29 miles, Ophelia is a mere speck when compared to the colossal dimensions of Uranus. To put this into perspective, if Uranus were the size of a basketball, Ophelia would be about the size of a grain of sand. Its small size makes Ophelia a challenging target for observation, even with powerful telescopes. Most of what we know about its physical characteristics has been gleaned from the brief flyby of Voyager 2 in 1986. The spacecraft's images revealed Ophelia to be an irregularly shaped object, lacking the spherical form of larger celestial bodies. The surface of Ophelia remains largely shrouded in mystery, a testament to the challenges of observing such a small and distant world. Voyager 2's flyby provided our only close-up glimpse of Ophelia, but the images reveal little detail about its surface features. What we can discern is that Ophelia, like many of Uranus's moons, is extremely dark, reflecting only a small percentage of the sunlight that falls upon it. This low albedo, or reflectivity, is thought to be caused by the presence of organic molecules, perhaps similar to those found in comets and other primitive bodies in the outer solar system. These molecules, darkened by billions of years of exposure to solar radiation and cosmic rays, would give Ophelia its characteristically somber appearance. Despite its small size and the limitations of our observations, scientists have been able to glean some insights into Ophelia's composition and internal structure. Based on its density, which is estimated to be slightly higher than that of water, astronomers believe that Ophelia is composed primarily of water ice, mixed with a significant fraction of rocky material. This mixture of ice and rock is consistent with the composition of other Uranian moons and supports the prevailing theory of planetary formation in the outer solar system. According to this theory, Uranus and its moons coalesced from a swirling disk of gas and dust that surrounded the young sun billions of years ago. The icy and rocky materials that make up Ophelia represent the primordial building blocks of our solar system, preserved in the depths of space. Studying the physical characteristics of Ophelia, though challenging, provides valuable clues about the processes that shaped our solar system. Its small size, irregular shape, and likely composition all point to a history marked by collisions and gravitational interactions. Ophelia's very existence, along with that of its fellow shepherd moons, highlights the delicate balance of forces that govern the Uranian system. By understanding the dynamics of this system, how its moons formed, how they interact with each other and with Uranus's rings, we can gain a deeper appreciation for the intricate workings of our cosmic neighborhood. Ophelia, though a small and unassuming moon, holds within its icy depths a record of our solar system's turbulent past, waiting to be deciphered. Ophelia circles Uranus at a distance of approximately 53,800 kilometers, or 33,400 miles, placing it within the planet's intricate ring system. This proximity to Uranus means that Ophelia experiences a much stronger gravitational pull than, say, our own moon does from Earth. This intense gravitational force governs Ophelia's every move, dictating its orbital path and influencing its physical characteristics. Unlike Earth's moon, which takes roughly a month to complete one orbit, Ophelia races around Uranus at a much faster pace. Its orbital period, the time it takes to complete one full revolution around the planet, is a mere 0.376 Earth days. This rapid orbital dance is a testament to the immense gravitational pull exerted by Uranus, keeping Ophelia in a tight, perpetual embrace. Ophelia, despite its diminutive size, plays a crucial role in maintaining the structure of Uranus's rings. It is classified as a shepherd moon, a term used to describe small moons that orbit within or near planetary rings, their gravitational influence shaping and confining the ring particles. These shepherd moons act like cosmic herders, keeping their flocks of ring particles in check. Ophelia's gravitational pull exerts a gentle but persistent tug on the particles of Uranus's Epsilon ring, the outermost and most eccentric of the planet's major rings. This gravitational shepherding prevents the ring particles from spreading out and dissipating into space, maintaining the ring's sharp edges and well-defined structure. Without the influence of Ophelia and other shepherd moons, Uranus's rings would likely be much fainter and more diffuse, lacking the intricate beauty that we observe today. Ophelia's gravitational influence on the Epsilon ring goes beyond simply keeping the ring particles confined. The moon's gravity also creates wave-like disturbances within the ring, much like a boat moving through water creates ripples in its wake. These waves, known as spiral density waves, are regions of higher particle density within the ring, creating a visually stunning pattern that resembles the grooves on a vinyl record. By studying the shape and propagation of these waves, astronomers can deduce the mass of the moon that created them, in this case, Ophelia. These subtle gravitational interactions between Ophelia and the Epsilon ring offer a unique window into the dynamics of planetary ring systems, providing insights that can be applied to other ring systems throughout the cosmos. Ophelia's orbit is not without its challenges. Sandwiched between the gravitational pull of Uranus and the influence of other nearby moons, Ophelia is constantly subjected to a complex interplay of forces. These gravitational tugs can subtly alter Ophelia's orbital path over time, creating a dynamic and ever-changing environment. One particularly intriguing aspect of Ophelia's orbit is its resonant relationship with another small moon, Cordelia. These two moons are locked in a 43 to 44 orbital resonance, meaning that for every 43 orbits Ophelia completes around Uranus, Cordelia completes 44. This resonance creates a periodic gravitational tug between the two moons, influencing their orbital stability. Ophelia's story, though focused on a single moon, highlights the interconnectedness of celestial objects within a planetary system. The Uranian system, with its giant planet, rings and retinue of moons, is a microcosm of the cosmos, where gravity reigns supreme, orchestrating a never-ending ballet of motion and interaction. Ophelia's orbit, shaped by the gravitational pull of Uranus and its neighboring moons, is a testament to the delicate balance of forces that govern our universe. Its role as a shepherd moon, maintaining the structure of the Epsilon ring, underscores the often subtle but profound influence that small objects can have on their surroundings. Among siblings, Ophelia's place in the Uranian system. Ophelia is just one member of a large and diverse family of moons that circle the ice giant Uranus. Currently, astronomers have identified 27 moons orbiting Uranus, each with its own unique characteristics and story to tell. These moons range in size from tiny moonlets, barely a few kilometers across, to massive Titania, the largest of Uranus's moons and the eighth largest moon in our solar system. This diverse collection of moons can be broadly categorized into three groups: the inner moons, the major moons, and the irregular moons. Ophelia belongs to the inner moons, a group of small dark satellites that orbit within Uranus's ring system. These inner moons are thought to be composed primarily of water, ice, and rock, similar to Ophelia, and play a crucial role in shaping and maintaining the planet's rings. Size matters. Comparing Ophelia to its lunar kin. Ophelia, with a diameter of 46 kilometers, is small among Uranus's moons. Titania, the largest moon, is over 30 times larger. Even Puck, the largest inner moon, dwarfs Ophelia. Size affects moons' shapes and roles in the Uranian system. Larger moons are spherical due to stronger gravity. Smaller moons like Ophelia retain irregular shapes. Orbital dynamics. A study in contrasts. Ophelia's orbit is governed by gravity. It completes one orbit in 0.376 Earth days. Miranda takes 1.41 Earth days. This reflects varying gravitational pulls. Orbital resonances add complexity. Section 4. Shepherds and Sentinels. Diverse roles in the Uranian entourage. While all of Uranus's moons contribute to the overall dynamics of the system, they play a variety of roles, their specific contributions shaped by their size, composition, and orbital characteristics. Ophelia, as we've seen, is a shepherd moon, its gravitational influence shaping and confining the particles of Uranus's Epsilon ring. Other inner moons like Cordelia and Bianca also act as shepherds, maintaining the structure of other Uranian rings. Meanwhile, the larger major moons, such as Miranda, Ariel, and Umbriel, play a more significant role in shaping the overall dynamics of the Uranian system. Their gravitational interactions with each other and with Uranus itself influence the planet's rings, the orbits of other moons, and even the tilt of Uranus's axis. A window into the past. Planetary formation and evolution. Ophelia holds profound significance in the solar system's grand tapestry. Its existence provides clues about planetary formation and evolution. Ophelia's composition is a relic of primordial materials. Studying these bodies offers insights into the early solar system. Analyzing variations refines models of planetary formation. A shepherd's tale illuminating ring. Dynamics. Ophelia's role as a shepherd moon, diligently maintaining the structure of Uranus's Epsilon ring, provides a unique opportunity to study the dynamics of planetary ring systems. These delicate structures, composed of countless icy and rocky particles, are found around all four giant planets in our solar system, each with its own unique characteristics and mysteries. By observing how Ophelia's gravity shapes and confines the Epsilon ring, creating wave patterns and influencing the distribution of ring particles, scientists can test and refine models of ring dynamics. These insights can then be applied to other ring systems, such as those around Saturn, Jupiter, and even more distant planets orbiting other stars. Understanding the forces that govern the formation, evolution, and stability of planetary rings sheds light on the fundamental processes that shape planetary systems throughout the cosmos. Beyond Uranus. Broader implications and future exploration. Studying Ophelia and Uranus offers insights into planetary systems' diversity and evolution, both in our solar system and beyond. Discoveries like shepherd moons reveal the significant role small bodies play in shaping planetary systems. These findings impact exoplanetary studies, hinting at unseen rings and dynamics. unlocking the secrets, future missions and discoveries. Voyager 2's flyby of Uranus in 1986 revolutionized our understanding of this ice giant and its moons. Future missions with advanced instruments could unveil new information about Ophelia's composition and surface features. These discoveries would deepen our understanding of Ophelia and the broader processes shaping our solar system.